Hey guys, this is Gavin once again, and yeah, so I thought it would be nice to kind of make a video where we discuss about Pythagoras theorem. Pythagoras theorem, why is it so important, and what is it used for, right? So let's start with the basic stuff. The basic stuff is who's Pythagoras? So Pythagoras is a Greek, or was a Greek. Was a Greek philosopher, and I'll put mathematicians as well at the same time, which is just many philosophers back then were mathematicians as well. So was a Greek philosopher and mathematician. So on top of that, he was a religious leader as well. So this is Pythagoras theorem. But one of the thing is he believed that everything around us, or maybe everything in the universe was made with numbers. Or maybe composed of numbers. So this is what Pythagoras believed in, right? So now, why is it Pythagoras theorem, and where this theorem comes from? So the idea of theorem is I'm gonna drop this a little bit down so that I can get enough room. So Pythagoras theorem it just help us to finding the size use the length of the sizes in a right-angled triangle. Right. So this is what we can use Pythagoras' theorem, and we're gonna draw shortly, but ideally, so you have this. Let's say you have this particular triangle. So with this triangle, we can see that this is a right angle triangle. So if I call this C, and I call this A, and this B, so in the end, what we have, so the theorem says that, or states that, C squared is equal to A squared plus B squared, which means vice versa. You could find one of these. You can always rearrange this and find one of these, C squared minus B squared, or B squared will be given by C squared minus A squared. What am I saying? What we are saying here is that this C, this C here is always the longest side of a triangle. No matter what, if you find that your B is greater than C, then that's wrong. Or if your A is greater than C, that's wrong. A and B can be equal, but C can never be equal with any of these. So C will always be the largest side. So that's one important thing to remember. So with that in mind, let's see how we can apply this Pythagoras theorem, right? So this is how we can apply. I've got one question here for us, and it's a beautiful thing because engineers would rely on this when they're making or they're dealing with angles of a house or a building or anything that they might want to build. So they can always relate to this, and you can see here a simple example, a simple application of this Pythagoras theorem, right? So a question here is. So allow me to rearrange this stuff. I've got a few questions for ourselves. Just give me some moment to kind of rearrange them so we have enough room. So in this particular question, a question is given to us where we are looking at a fire brigade attend a blazer in a tall building. They need to rescue a person from sixth floor of the building, which is 30 meters above the ground level. The ladder is 32-meter long and it must be at least 10 meters from the foot of the building. Assess whether the ladder can be used to reach the people needed rescue. So you can see here how math can be applied in pretty much everything around us, right? Math is always around us. So here's a simple application where people need to be rescued, but we need to apply this. We need to keep track with these mathematical knowledge or concept in order to save them. All right. So what we're gonna do here, I'm gonna sketch this. It's always when you're approaching this problem solving question, have a diagram, right? Sketch this because it shows the understanding, or it give you an edge when it comes to when you start. You can always relate to the diagram that you have and find out what you're doing wrong or what you're missing, right? So, and I'll do this and. So I'm gonna call this as my building. And then what we know is this thing is 30 meters. 30 meters. And so this is the building. So so this is our building, and they told us the sixth floor. So we're gonna assume. So my diagram is not accurate, but we're gonna assume that it's accurate, right? So that means the fire is happening in this floor here. Since the fire is happening in that floor there, and then they told us the ladder is 10. So they told us the ladder is 10 meters from the floor, right? And then the height of the ladder is 32 meters long. So what I'm gonna do is we're gonna assume from here to up here is 10 meters, and then we're gonna have this 32-meter ladder going up to this building. So this is our ladder. Alright. And so so now we know that this ladder is 32 meters. 32 meters. and then we know this part here. This part here is 10 meters. So the question asks us, hey, assess whether the ladder can be used to reach the people need rescue. Alright. So you can see this, how the triangle thing is coming in, and then so what we're gonna do is we're gonna try to assess, because you can see the ladder in the building. If you put them vertically, the ladder is longer than this, but then now the question is asking us to find whether to assess whether if this ladder will be enough to reach that way. Because of this, we are pushing back 10 meters. Why we are pushing back 10 meters? To get the balance, right? We need to get that balance. So in order to get that balance, we need to push back 10 meters. So now let's approach this question. So I'm gonna transform this question as actually a triangle, and the triangle would look like this. The triangle look like this. So we know this is 30, and we know this is 10. What we wanna do is we wanna treat this as L. I'm gonna call L. But then now if you wanna find the L, we're gonna apply the Pythagoras theorem, which is C squared equals to A squared plus B squared. So now we're gonna apply the same thing here. So L squared should equal to 30 squared plus 10 squared, which is 900 plus 100, so which is equal to 1,000. This is 1,000. L squared equals 1,000. But if you are looking for L itself, right? L itself will just be square root of 1,000. Alright, so I'm gonna use my phone. I don't know why I put my calculator. I'm gonna use my phone to get a calculator, and then we should be able to find the answers that we're looking for. So square root for 1,000. So according to my calculator, it's approximately 31.62. So therefore, the length that's needed, would be equal to 31.62 meters. But this is not the question. The question asks us, assess whether the ladder will be can be used to reach the people, right? So now we can make a second statement. Therefore, the ladder, since the ladder is since the ladder is 32 meter long, and the height at 6th floor is 31.62. It's evident that this ladder can be used. And I don't mind how you wrote this or you write this, but as long as you make this statement, it will be good. Alright? So that's how this Pythagorean theorem works. So you can see how important it is, like a simple from a very applicable how we word problem. You can see how we have applied we sketch a diagram from diagram. We expand to get our triangle from the diagram. After that, I write down the formula, substituting the values. Once you substitute the values, evaluate the values, get the solve for L, which is just some letter, solve for L, and then you get 31.62, and so on. But I realized that one thing that could happen, the worst case scenario, is if you decided to round this 31.62 to 32. It will still be okay, but then you can see why then when we round, we are losing quality, we are losing the accuracy, right? So sometimes we do not prefer to round so that we can see the big picture. Otherwise, if you decide to round, you may lose quality, right? You may lose accuracy if you want. Right? So that's the first question that we've got. I'll do two more from question 8, and then we'll kind of move forward. The next one. So the second one, here the question is: are the following set of numbers Pythagorean tribes? But what are they saying? The question is asking, well, if you've got these three numbers, and then we know the theorem says c squared is equal to a squared plus b squared plus b squared. If you substitute these numbers into any of them, would they be equal, right? So check. You always take the largest number, which is 15. So we're gonna do a, and then maybe what else? I don't know. We'll try a and c to see what happens. So for a, so you will take 15 squared is equal to 9 squared plus 12 squared. This is what we want to assess. So this is 225. This is 81 plus 144. And so this is 225. Is he? Yeah, this is 225. And this is 225. Right? Since they are equal, therefore 9, 12, 15, and 12, 15. 9, 12, 15 are Pythagorean tried. Yeah. And then as I said, we'll try C as well to see what happens. So with C, same formula. So we'll take the largest side. 50 squared is equal to 40 squared plus 30 squared. And so this is 2500. And then this is the 1600, 900. And again, this is 2500. I might squeeze in another one. Let's do D as well. D. So we'll take 9 squared is equal to 6. 3 squared plus 6 squared. This is 9, 36, 81. This is 45, 81. Therefore, you can see that on this one, on D, therefore, 3, 9, 3, 6, 9 are not Pythagorean, right? So this is the difference. You can see the first ones. When they are equal, then that means they are Pythagorean triads. And when they are not equal, like this one, you can see that they are not equal. They are not gonna be Pythagorean triads, right? So that's how we solve this question. And the next question is calculate the value of x to the correct two decimal places. I love this question for some reason. It's just a combination. It's a bit advanced question from what we are doing, but I thought it would be nice to just have a crack on it. Two things happen in this question. We're gonna stick to the plan and apply the Pythagorean theorem, and we might need to apply use a few other formulas that I might share. Let's see how that goes. You can see that we've got two triangles, if you want, maybe three. Maybe we got three triangles. The first one is this, which is great. The second one is everything, the bigger part of it. And the fourth one will just be this, which we are not gonna be interested in. So what I'm gonna show you is I'm only gonna focus on the first one here, this one first, and then see how it goes. So with that one, we already have this side here, and we can see that's the right angle triangle, and we've got this side here being 8, but we are looking for x. We are trying to solve for x, but we also know the hypotenuse for this. So if I look for this side that I just highlighted, it's not gonna help me much, because even if I get this side here, even if I find this is not right angle triangle, I won't do much, because Pythagorean theorem only works or applied, or it can only be used for right angle triangle. Remember when we describe it, right? So I'm no longer gonna do that. So what you wanna do is you wanna look at the big triangle, the whole thing, right? You wanna look at the whole thing, because we know with Pythagoras, this is what we saw earlier, or what we agreed on earlier. So if this is A and this is B and this is gonna be C. Now, if you know two of this side, you can solve for the other ones, right? So, and that's the case that we've got here. It's just the only difference here now. We've got B is gonna be B plus X, but we don't know what X is, right? So let's do that. So we know that C squared is gonna be equal to A squared plus B plus X squared. So then we have the value of A, we have the value of C, so that will be good, because then we can rearrange, say B plus X squared is just equal to C squared plus A squared, sorry, my bad, minus A squared. And from here, B plus X with our power is gonna be square root of C squared minus A squared. Well, allow me to substitute in the values. So we know C is 22 and 15, right? So here we're gonna have 8 plus X is equal to 22 squared minus 15 squared. So Y know this is 225. 22 squared, I will use my calculator. My brain, it's not working, it's not as sharp as it should be at this time of the day. So 484, and then subtract 225, we get 259. Right? So far so good. But what is square root of 259? Right? Give me a moment, I'll copy this down. 8 plus X, 8 plus X, and then now I'm solving for that 259. So we need to find the square root of 259. Come on, guys. 259. It's not that hard. It's one of the kind of very close number, huh? So 259, according to my calculator, it's gonna be approximately 16.09. So 16.09 is equal to 8.6. Since we got 8 plus X being equal to 16.09, then we can solve for X. Subtract 8 on both sides, minus 8 on both sides, minus 8. Then we end up with 8.09. That's the value of x. Now you go back to the question to two decimal places. That's what they said. And so therefore you can always put that statement. Therefore the value of x is 8.09. Did they pull unit? No, they did not pull unit, so we don't have to pull unit as well. Full stop. So I hope this question makes sense. Let me know how you feel about these questions, and I'm happy to kind of be spending at least 10 to 15 minutes doing one of these per day, if they are helpful to you. Thank you very much, guys. I appreciate your support. So remember what we discussed earlier: Pythagoras Theorem. Pythagoras is the name of person. They actually, his full name was they used to call him Pythagoras of Samoas. So he was a Greek philosopher and a mathematician. On top of that, he was a religious leader. Right? He believed that everything in the universe was made of numbers or composed with numbers. His theorem, or Pythagoras theorem, he has many theorems, by the way, but this Pythagoras theorem is used to find the size, one of the sizes, or the length of the side. The length, I found a mistake. The length of the side. The length of the side in a right angle triangle, as long as you have two sides. So as long as you know two of them, as long as two sides are known. Right? So then you can see in this triangle, we go C is always the largest side or hypotenuse, and then we go A and B, which is just